just start. Yeah, there is also a different category which is tensor quantity. Like we have three quantities total: scalar, vector, and tensor. Tensor is basically vector quantity only, but that has multiple directions. Like vector has a fixed direction, right? But scalar is, it has more than one direction. For example, if we take an example of pressure, what is pressure? Force upon area, right? Pressure is force upon area, right? So the exerted pressure is from every side. The magnitude is also different. The direction of force is also different. Yeah, you can see here. The force is from all sides. So this is the tensor quantity. That is a vector quantity but has multiple directions. We can use Polygon law here. Like it has more than two vectors and could be used here. So let's just not go there. There's a beautiful application of vectors, right? Let's just start with that. As we know that association of two vectors, let's just take this f1 and f2, gives you resultant r, right? So law, there is a law for that, because you can't use basic geometry here, right? It become complex. So we had developed a law for that is law of triangular law of vector. Like we can just put this vector here to make a triangle, and this adjacent side, I mean this resultant, is what you call hypotenuse, right? So we can use Pythagoras theorem here. Hypotenuse square is perpendicular and base plus base, right? We can use this. So this is the standard representation of this. R vector is equal to A plus B vector. That doesn't mean we add these two. It's totally different. That is how we represent this vector. The formula is quite different. Like there's another law which is Polygon law, which I explained you earlier, right? If we have two vectors, we put them to the adjacent to each other, and the resultant vector is diagonal, and this matters only for few cases that in which point of application matters, right? For example, let's just take an example of flying bird, right? It flows like this. Newton's law, every action is equal and opposite reaction. तो वेक्टर तो ये ऊपर जाएगा ना, the flapping backs, and the resultant vector is this, diagonal. This is what it means. So I started the laws quite earlier, but now just let me explain the Polygon law. For example, if you have multiple vectors, not one, multiple vectors, 2, 3, 4, 5, I'll explain you here. Vector C. Now you just add these vectors. Let's just say A, B, C, and D. I think okay. We'll just add these two vectors according to the placement of these arrows. I'll just make a quick. This arrow is horizontal. We add this. This arrow is like this, so we do this, and this is straight. Similarly, this is downwards. Yeah, this is the resultant. So we use Polygon law for Polygon law, A, B, C, and D vectors. This is R. r is equal to a vector plus b vector plus c vector plus d vector. This is how we represent, but that doesn't mean we add these two. We don't add these. The vector addition is different. We use Pythagoras, perpendicular hypotenuse, like perpendicular base hypotenuse to perpendicular base ka square, right? We use this only to explain. Yeah, before going further into the video, let me give you a little idea of common definitions basically. So we have few common definition. First is, I'm not explaining any, I'm just explaining it for quick. We have equal vectors, right? That has equal magnitude and direction is also into the same direction, right? Unequal vectors that has unequal magnitude and direction is also different. What is negative? And there's a negative vector as well. The magnitude is like equal, but the direction is different. That is what else? Yeah, the initial, co-initial, that has same starting point. Coterminous, that has same ending point. Like, and what else? Coplanar, parallel to each other. I mean, not parallel, same plane basically. XY, let me put this x y plane. So this is in the same plane. Vectors are in the same plane, XY plane only. That is it. And the last one is like parallel to each other. I'm forgetting that one, but you can get through the definition. Doesn't matter, because these are just definitions only. Doesn't matter. And there are two special terms that I forget to explain. The first is polar vector. Polar vector. What is polar vector? That has a initial starting point basically. The best example for polar vector is displacement. You need to have like initial and final position, right? That initial minus final gives you displacement, right? So yeah, so you ought to have that. And there is an axial vector as well. Axial vector is basically a vector that is represent the angular momentum, or angular displacement of for example, I'll make a diagram. So this is omega, right? This is like this we need 3 points for this: the center, final and initial and final point, and this is displacement is theta. Yeah, so any vector that has 3 points, final, initial, final, and that has a point of origin which is axis, point of center here. So this is axial vector. And you know that what is omega? Omega is, if I explain you in short, is theta by t. Yeah, angle into time gives you omega, and that you will learn later. So I'm not explaining this. So in short, anything that has angular momentum, basically rotational motion, has axial vector, right? That's the basic conclusion of this. Well, pretty much it for now. So the few I'll explain you later now.